already talked about the lengths of chords within a circle, we're going to talk about the relationships between the lengths of tangents and secants. Well, it turns out that if I have a tangent and a secant that are drawn to a circle from some common external point, then the square of the length of the tangent segment is equal to the product of the lengths of the secant segment and its external segment. Now that's a really wordy way of explaining a very simple concept. First, let's talk about what the tangent segment means. The tangent segment is the length from the common external point to the point where the tangent line touches the circle. So that would be AB in this case. So AB squared, the square of the length of the tangent segment, is equivalent to the product of the entire secant segment, which is the length from the common external point to the end of where that segment hits the circle. So the further point of intersection between the secant segment and the circle, that's BD in this case. So it's the product of BD and the external portion of the secant segment, which is the segment between the point of intersection and the closer point of intersection with the circle, BC. Okay, so the square of the tangent segment is the product of the secant segment with its external segment. In a numerical example, we can look at this relationship where I have tangent segment PA to circle O and secant segment PBC, where PB is 4 and BC is 8. So let's label some parts. PB is 4, BC is 8, those are those two parts, and I need to find the length of PA. So I'm going to call PA X. So the length of the tangent segment, PA, is X. Well, the square of the tangent is equal to the product of the external portion of the secant, PB, which is 4, with the entire secant segment. Now the entire secant segment is the length from P all the way across the circle to C, which is 4 plus 8, or 12. So it's the product of 4 times 12. Well, that tells me that x squared is 48, and when I take square roots, I get that x is the square root of 48. Now, normally when we take square roots of both sides, we have to account for both the positive and negative solution, but since x represents the length here, it's not possible for it to be a negative. What's left is I simply need to reduce this radical, which gives me 4 square root of 3. So the length of PA is 4 rad 3. We could also have a combination of two secant lines. Now, much like the other one, it's the product of the entire secant line of the first secant, AC, with the product of its external segment, BC, is equivalent to the product of the external segment of my second secant line, CE, with its external segment, CD. Okay, so it's the whole segment times the external part is equal to the whole segment times its external part. Again, using a numerical example to get a clearer picture of this. In this case, I have segment AB is 8. I have segment AC is 25. And I have segment AD is 10. I'm looking for the length of segment AE. So I'll call that X. So I'm letting AE be X. Well, just like before, the length of my first secant, the red segment, 25 times its external bit, which is 8, will be equal to the product of my other secant line, x, and its external bit, 10. So I end up with 200 equals 10x, which when I divide by 10 gives me x is 20. So segment AE is 20. Okay. Our last combination of segments is two tangents, and this is actually our easiest relationship to remember. If two tangents are drawn to a circle from an external point, then the lengths of those two tangents will be congruent. Which means that PB is equal to PA. So in this numerical example, when I have two tangents, those two tangents are exactly equal. So x will end up being 12. Let's apply these ideas to a couple more examples to get a better feel for them. In this question, I have a circle inscribed in a triangle, meaning it touches the triangle at one and only one point on each of its sides. You could also say that the triangle is circumscribed around the circle. And since these lines touch the circle at one and only one point, it makes each of these segments tangent. So this segment of length 2 will be equal to this tangent, which shares a common point with it. So it will also be 2. And similarly, this tangent of length 3, which shares a common point with this tangent, will have the same length. So it will be 3, which means that x will be equal to the sum of those two segments, 2 plus 3, or 5. Let's look at an example with some secant segments. Here, I have two secants drawn to a common point, P, that are secant to this circle, where DC is 8, PC is 12, and AB is 14. I'm trying to find the length of PA, so I'll call that X, and that's my segment here. Well, recall that when I have two secants, it's the length of the external segment times the entire secant segment, which means that in this example, I'll need to know the lengths of these entire secant segments. Well, PD would be 12 and 8, which gives me 20. And PB, a little more challenging, is 14 plus X, or just X plus 14, the combined total length of those two segments. So when I set up my relationship, it's the external piece of my first secant line, which is 12, times the entire secant line, which is 20, is equal to the product of the external piece of my other secant line, which is X, times the entire length of that second secant line, which in this case is X plus 14. Well, that gives me 240 is equal to, and I'll have to distribute here, X times X gives me X squared, and X times 14 gives me 14X, which when I write that in standard form gives me X squared plus 14X minus 240 is equivalent to 0 when I bring that 240 to my other side. And now I'll factor and use the zero product property. I get X plus 24 times X minus 10 equals 0, meaning that one of those two factors must be 0. So X plus 24 is 0 when X is negative 24. And X minus 10 is 0 when X is equal to 10. Well, now, unfortunately, since this X represented a length, it can't be negative, so I'll reject this answer, which tells me that the length of PA must be 10. Okay. There are several other examples in this packet I'd like you to work on, the solutions to which can be found on the portal.